All right, students, welcome back. So the power rule for exponents. If I have an exponent raised to another power, I'm going to multiply the exponents. So Sarah wrote 3 to the power 5 is raised to the power 7, so that equals 3 to the 12th power. Correct her mistake. So we know she's wrong. What did she do? Okay. We know if it was 3 to the 5th power times 3 to the 7th power, then I would add the exponents, 5 plus 7. But we're not doing that. We have 7 groups of 3 to the 5. So we have 7 groups of those. So it's 3 to the 5, 3 to the 5, 3 to the 5, 3 to the 5th power, 3 to the 5th power, 1, 2, 3, 4, 5, 6, and 7. So that's 5, 10, 15, 20, 25, 30, 35 threes. So write it a little better. 33 to the 35th power. Right? So what was her mistake? She added when she should have multiplied the numbers. Right? So let's try exercise 6. A number y satisfies y to the 24th minus 256 equals 0. What equation does the number x equals y to the 4th equals? So if I'm going to do that equation, I have x equals y to the 4th. How many y to the 4ths are in 24? So if I divide that 24 by 4, that's 6. So I have 6y to the 4th in y to the 20, x y to the 24th. So that means I have x to the 6th minus 256 equals 0. Making any sense to you? That one's a little hard. Just a little confusing. It's not really hard, it's just confusing the way they're doing it. So any number x and y and positive integer n, x, y to the nth power equals x to the nth, y to the nth. So we prove that because x, y to the nth power is xy times xy times xy times xy n times, and then through the magic of the commutative power, we can split those up and move all of our x's on one side and all of our y's on the other side. So now I have x times x times x n times, and I have y times y times y another n times. So I have x to the n times y to the n. Does that make sense? So let's take a look at this problem right here. 11 times 4 raised to the 9th power. So what they're saying, basically, if I have the numbers inside, then I can just split them out. So x, y to the nth is x to the nth, y to the nth. That means here, let's call that my x and that my y. So if my x is 11, I would have 11 to the 4th times 4. Sorry, 11 to the 9th times 4 to the 9th. That's all it's saying. Exercise 8. 3 squared times 7 to the 4th, all that raised to the 5th power. So split them up, and each of them is going to be raised to the 5th power. So I've got my 3 squared raised to the 5th power times 7 to the 4th raised to the 5th power. So what's 3 squared raised to the 5th power? So that's 5 groups of 3 squared. So that's 3 to the 10th and 7 to the 4th power raised to the 5th power. So that's 5 groups of 7 to the 4th power. So that would be 5 times 4 is 20. So I have 3 to the 10th power, 3 to the 10th power times 7 to the 20th power. Exercise 9. A, B, and C are numbers. 3 squared times a squared, a to the 4th, all of that raised to the 5th. So I'm going to say, I'm going to split them up. I've got my 3 squared and my a to the 4th, and both of those are raised to the 5th. So I have 5 groups of 3 squared, so that's 3 to the 10th, and 5 groups of a to the 4th, so that's a to the 20th. Exercise 10. Let x be any number, 5x to the 7th. So I'm going to separate those. 5 to the 7th power times x to the 7th power. That's all. If I take a look at the next one, 5xy squared to the 7th power. I'm going to split them up. I've got 5 to the 7th power times x to the 7th power times y squared to the 7th power. So y squared, 7 groups of that would be y to the 14th. So I have y to the 7th, x to the 7th, y to the 14th. 14th. Can you do exercise 12 then? Let A, B, and C be numbers.